reads, positive allosteric modulators can amplify endogenous signaling in a context-dependent way. How do you account for the variability when translating from a cell-based assay to a disease model? That's a loaded question and can be really important. The short answer is this is where it gets tricky, and it's this age-old question of translation. Translating our nicely controlled in vitro systems to a highly uncontrollable in vivo one. Give you an example. I was working with a company, and they were trying to make analgesics for the opioid receptor, but they were trying to use PAMs. So no direct opioid agonism. They were worried about respiratory depression and so forth. They were going to potentiate the natural enkephalins and so forth in a brain, which is great. In a controlled system, you can get the curves at alpha, betas. The problem they had was now they put it in animals with varying enkephalin levels in a brain. And so they got varying, what they would consider therapeutic effects. That's what I assume they meant by context dependent. And other than trying to delineate the limits of your allosteric molecule, get the maximal shift you can see, like cinacalcet was what, 2.5 fold. At least you know that. Then you put it in a system, but it's going to vary in terms of the, let's say it is an opioid effect, in the regions of the brain in response to the natural levels of ambient agonism in those regions. And that can lead to a very complex effect. Worse than that, those effects, those patterns could vary between a mouse and a rat and a person and an aardvark. So now you've got species dependence coming into it. So this is sort of why allosterics are a two-edged sword. I love them. I think they are potentially powerful tools, but they're going to be a little more difficult to develop. They're probably getting easier to discover now, especially with binding receptor structure, cryptic sites, and all that stuff. But once we have them, it's still the translation fold. I might add, if we consider biased signaling allosteric probe dependence, which it is, that's all it is, it's the same thing. That's why translating bias is tricky as well, because it becomes context dependent. And so I always argue, work out your bias assay or an allosteric assay. You can characterize your probe. Is there a need to then go, oh, okay, I'll do this hex cells and COS cells and this cells and CHO cells? No. Once you have identified the molecule, because that assay is simply telling you this molecule stabilizes a unique site, and that's going to happen in every system. So that will not be context dependent. How it plays out will be. So you get your probe. This is my probe. Go to the natural and therapeutic system as fast as you can. Don't waste time with different cell lines and expression levels and all that stuff. There are reasons to do that too. But if you're mainly concerned with translation, you could spend years doing that and still not predict the right phenotype. Get into hopefully the therapeutic system quickly. So let me relook at that question. Did I answer it? Yeah. Accounting for them being variable will be reflecting the variability of the context. Yeah. Okay.